All right, welcome everybody. So far we've talked about kinetic energy, potential energy. Now what we're going to look at today is some concepts related to those two types of energies. So remember that gravitational potential energy is dependent on the height of an object. So in other words, the higher an object goes, the more potential energy it has, and the lower it goes, the less potential energy. Kinetic energy is dependent on how fast something is moving. So the faster something moves, the more kinetic energy it has, and vice versa. Elastic potential energy is related to how stretched or how compressed something is. Typically, we'll see that with balls that bounce, like basketballs or footballs or soccer balls. You might see them in springs. Springs can be stretched or compressed. And then we've got no energy and a combination of multiple energies. So what we're going to do is we're going to read some examples here, and we're not going to go through all of them. I'm not going to go through all of them with you. I'll go through a few of them with you, and then you'll have some time at the duration of the period to complete any remaining questions. So we're looking at some scenarios, and we have to determine what type of energy is being described. And then you have your potential or your answer choices up here. So let's look at the first one. Number one says a roller coaster car is momentarily stationary at the top of the first drop of a tall roller coaster. So based off of what I see here, I've got this roller coaster car that is momentarily stationary. So that's telling me that it's not moving. In other words, its velocity is 0. So that should tell you right then and there the object is not moving, so it will not have any kinetic energy. If we keep reading, it says it's at the top of the first drop of a tall roller coaster. So it's implying that it has a lot of height. Okay? It doesn't mention anything about anything being stretched or compressed. So all that I'm really looking at here is one type of energy, and it's the energy that's dependent on height, which is gravitational potential energy, which is answer choice A. In number 2, it says a dragster accelerates along a drag strip to a high speed. So based off what it's telling me that it's moving very fast, which means this object has a lot of velocity. So a lot of velocity leads me to believe that there's a lot of kinetic energy. It says the dragster accelerates along a drag strip. So drag strips, if you're not familiar with them, they are flat, level surfaces. So there's no change in height. This dragster is not increasing height. It's not decreasing height. So its height is not changing, which leads me to believe that there's only one type of energy here, and it's kinetic energy. I'll do one more with you guys. Here on this side, number 3 says just before rebounding back upward from the hardwood floor, for a moment in time, the stationary bouncy ball is compressed into a non-spherical shape. Okay, so a couple things here. It says it's stationary, which means there's no velocity. So that tells me that it's not kinetic energy. It says the bouncy ball is compressed into a non-spherical shape. So we're taking a normally spherical ball and it's being compressed against the hardwood floor, causing it to form a non-spherical shape. So anything that is being compressed or stretched is elastic potential. Okay. Now, this ball is on the floor. Okay, so it's at its lowest position. So that tells me that there's no height involved. The fact that it's stationary tells me there's no velocity, no kinetic energy, but it is being compressed. So the best answer here would be elastic potential energy, which would be answer choice B. Okay, so I want you to read through the remaining scenarios here and answer through number 10. I'm going to move on to the right side of this page. Okay, I've got a few examples here. One, you've got a wrecking ball that's swinging, and it's showing you position 1, position 2, position 3, and position 4. At what point of the wrecking ball should the ball make contact with the wall to have the greatest kinetic energy? So remember, kinetic energy is dependent on velocity. Okay, so think about in the notes, what we're forming here is essentially a pendulum. Okay, we talked about the pendulum yesterday. Think about where the wrecking ball here would have the highest velocity. Wherever it has the highest velocity, that's where it's going to have the greatest kinetic energy. And that'll give you your answer. Okay, in number 12, we're looking at three mountain climbers. We got mountain climber climbing path A, path B, and path C. Okay, yes, some of them are taking a more direct path, some of them are taking a more indirect path. But it's asking you, the question is, which person gains the greatest amount of potential energy? Remember that potential energy depends on height. Okay. So as you're looking at the pathways that the climbers are taking, think about height. You want to figure out which one has the greatest amount of potential energy. That's based off of height. When I look a little bit further down here, we've got a diagram that helps you answer 13, 14, and 15. So you've got a ball here at position A. It's rolling down the hill to position B, and then it starts coming back up the hill to position C, D, and eventually to E. Okay? Now, remember your rules for potential energy. Potential energy is dependent on height. So ask yourself, where is the ball the highest? Wherever it's the highest, it has the most potential energy. Okay, kinetic energy is dependent on velocity. So where do you think the velocity of this ball would be the fastest? Okay, wherever it's the fastest, it's going to have the most kinetic energy. So ask yourself those questions. Look at the points. Okay, not all points are at the same height. Therefore, the ball is going to be doing something different at each point. Okay, while you're thinking about this diagram, I want you to try to answer 13, 14, and 15. One thing that I will tell you is that D and E are at the same height. D and E are at the same height. And in number 13, it says, as the object moves from point A to point D across the surface, the sum of its gravitational potential and kinetic energies is what? So this word sum means that you're adding them up, the gravitational potential and kinetic. In other words, it wants to know the total. Think about what you know based on what we talked about yesterday. What is true about the total energy as an object moves from point A to point D? So answer those questions that are remaining on page 5. Go ahead and turn over to page 6 for me really quickly. And again, at any point, if you need to stop and make notes, just pause the video and come back to it. So I'll go over a couple things on page 6, and this is what you're working on today in class, page 5 and 6. So now you're given some more scenarios similar to what we did on the previous page. But I want to know, based off of the energy that's listed, is that energy increasing, decreasing, or is it remaining constant? Okay. So, for example, in Roman numeral 1, it says a ball is falling from the second floor balcony to the floor below. So I want to know two things. I want to know about the kinetic energy and the potential energy. So if the ball is falling, that means it's starting at one position and it's going downward. So what's changing? Well, the height is certainly changing. We'll say that height is decreasing. Velocity. We know that as things fall due to gravity, their velocity increases. Okay? So based off of that information, number 16 wants to know about kinetic energy. Well, if the velocity is increasing as it moves down, if the object is speeding up, then that must mean that the kinetic energy is also increasing. And the potential energy is dependent on height. So, if the ball's falling, obviously the height is decreasing, the height's getting lower, therefore your potential energy is also decreasing, it's getting lower. Okay? When I look at Roman numeral 2, it says a car skids to a stop along a level roadway. So I want to know about the car. I want to know about the car's kinetic energy and the car's potential energy. So let's say this is the surface that the car is on. Here's my car, and the car is moving this way. So if the car is on a level roadway, that means that there's no change in height. So if there's no change in height, then that means that my potential energy must not be changing either. So if there's no change in height, then the potential energy is remaining constant. And then it says a car skids to a stop. So if you are coming to a stop, then your velocity has to be slowing down. Therefore, your velocity is decreasing. If your velocity is decreasing, then that means that your kinetic energy must also be decreasing. Answer choice B. So what I'd like you to do is when you finish page 5, come back to page 6 and ask yourself these types of questions, okay? Is the height changing? If the height is changing, then the potential energy is changing. Is the velocity changing? Is it speeding up or slowing down? If it's doing one of those things, then that means that the kinetic energy is also changing. If the height doesn't change, then there's no change in potential energy. If the velocity doesn't change, then there's no change in energy of kinetic energy. Okay? So ask yourself these types of things. Try to maybe visualize or draw out the scenario to help you understand it, and identify if the energies that are listed are increasing, decreasing, or remaining constant. So your objective for today is to complete the remaining questions on page 5, turn over to page 6, and complete all the questions on page 6.